Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Disruptive Private Clouds with Aaron Reid from Verge.io. Aaron, welcome to the show.
Hey, Darren, thanks for having me.
Aaron, this is your second time on the show. Last time you were on with Chris, and I've also had your CEO on from Verge. I'm kind of enamored with you guys. I think you already know this. I like your approach to virtualization to the software-defined infrastructure layer, and you've got some really cool stuff you've been working on. But let's first, before we dive into the really cool stuff, let's talk a little bit about the difference between virtualizing just VMs and virtualizing data centers or tenant, or that concept that you guys have that's so different than what we're seeing in the industry today.
Sure, you bet. Thanks. So one of the specialties around Verge.io that we do is, and I think you were going to mention it, is our multi-tenancy and being able to abstract the virtualization of your resources into tenants. And what we do with that basically is we start with a tenant, and the tenant is what a lot of people call nested virtualization. And we put that in a segregated environment. And that starts with a zero trust architecture when it comes to the networking side of it. So you create that subtenant, it has a zero trust architecture. People can't actually get access to that subtenant until you give them access through the networking rules with firewall rules and routing, etc. Once that's set up, you can do things with that subtenant, like you can do unlimited snapshots across the entire subtenant. You can do, you can allocate resource on demand, CPU, memory, RAM, and storage. So for example, if I start with a subtenant for one of my end users or a group, say a research group, for example, and they say we need 24 cores and 48 gigabytes of memory and 5 terabytes of all flash storage. Later on down the road, as they're going through their testing, they may come back and say, well, now we need 10 terabytes of storage. I can easily and dynamically allocate that storage out to that tenant for them to use. It's all non-disruptive. It's just a matter of on demand. Oh, I have the storage in the back end. I allocate it up to my tenant from the backside, and they have access to it now.
No, also you do more than just, because that sounds like, oh, that's just one VM, but that's not one VM. A tenant can have multiple VMs and network configurations, all that. Is that correct?
Yeah, absolutely. It's just like if you would, we like to call it a virtual data center, quote unquote. But it's the same thing almost as if you were to go to public cloud and say you wanted a AWS VPC, a virtual private cloud, or if you went to Azure and you wanted a security group. It's the exact same thing. A tenant is a whole infrastructure construct where you can go up and spin up VMs, you can create networks, and then you can protect it with snapshots, unlimited snapshots on replication. So we can take those tenants and replicate them to other sites, etc.
So that means I have portability of that tenant, which to me, this is actually pretty cool because I can create a full-blown data center with hundreds of virtual machines, several different networks. I can do all that, snapshot it, and do DR.
Absolutely. Yep.
Right. Or even better, business continuity as well, right?
You can do DR, you can do business continuity, you can even templatize those tenants. So for example, maybe I have a testing environment and I want to make a clone of that testing environment for another group. Maybe I'm moving it from dev to test to QA. I can literally take that tenant. It might have an application stack of 20 VMs in it. I can do a snapshot and clone it off within seconds and then provide that as another environment for someone else to test on.
Oh, my brain just went in crazy directions. So, which happens a lot. People that listen to the show know this about me already. That means I could actually set up a HIPAA compliant tenant that has VMs that are running, that are doing logging and all the protections I needed, maybe even have in there an identity access management tool. All that. I could have all that in one tenant, and then I can deploy that wherever I want.
Yep, exactly.
So if I'm a healthcare service provider, for example, one of the big conglomerates like Sutter Health, who my friend is a lawyer down there, so I'm going to pick on them a little bit. If I have these small businesses that I've been acquiring, and I say, hey, we need to make sure you're HIPAA compliant, boom, done. right? I
Yep,
can drop a tenant
absolutely.
on them and they can start adding their own VMs to it and done.
Yeah, they can build into that tenant with new greenfield VMs, and or if they already have an environment that's like a their own infrastructure that's already built up, they can move their VMs into that tenant as well. And then, like you said, it's
Oh,
already HIPAA compliant.
yeah. So this is cool too. I can migrate from other VMs into this new environment and now I'm compliant.
Yep, absolutely. And we can migrate off the major virtualization vendors in the market today: VMware, Hyper-V, KVM, you name it, and we can pull them right into our environment.
This is super cool. And that's why I'm enamored with you guys because every time I talk to you, I learn something new that now I'm thinking of my customers. What can I do for them? There's lots of really cool things I could do for them.
Yeah, we just did an example the other day. I created a video because we have a customer that we're talking to right now, and they run Hyper-V in their environment, and they want to be able to migrate from Hyper-V into Verge.io. And they asked, well, what's that process look like? So I created a video for them. It's not up on our website yet, but I could share it with you guys. But literally, the video walks through how you go in and you look at your Hyper-V VMs, because Hyper-V is used in a lot of smaller shops, but professional, kind of small to medium sized shops. And but a lot of customers are starting to move off of that because they're not sure which direction they're going to go. And so what we enable them to do is literally take their VMs. All you have to do is turn off a VM, import it into our environment, and then turn it back on, and it's up and running.
So pretty straightforward. The only time it takes is probably just moving it from one environment to the other, right? Moving the file, the definition. Can't remember what they're called. I used to know this.
Oh no, it's the Hyper-V VMs, or for any VM for that matter. You're spot on. It's just a matter of the time it takes to take that VM file. If
And
VMware, they
move it.
call it a VMDK, yeah, Hyper-V, they call it a VHDX, and move it across the pipe. So the bigger the pipe you have, it's a 1 gig pipe or a 10 gig or a 25 gig pipe, it moves that much faster.
Wow. Wow. So
Yep.
that's pretty simple. Now, what about moving? Because all the cloud service providers are all running virtualization techniques, and obviously Microsoft is running Hyper-V on their cloud, right? And I can't remember AWS. I think is running Zen, right?
KVM, QEMU.
KVM. Yeah, key.
Yeah.
So can I snapshot something out of the public cloud and put it into a private cloud this way or not?
Well, you would have to be able to export one of your instances. Depending if it's software as a service, we probably couldn't do that natively because software as a service runs as their own services in
Right,
their cloud. But
right.
if it's an instance VM, if you're backing up that instance, you could back it up and restore it in our environment. I don't know though if you could do just a native, copy from one cloud to the next.
Gotcha. But there might be a path there that I can explore to repatriate maybe even some workloads are running in the public cloud.
Oh yeah, absolutely. Yeah, we have customers doing that today. And a lot of times they do that is they don't have to really rebuild so much if it's running on a standard instance, like if it's on an Ubuntu Linux instance or a Windows
Right.
instance or a CentOS instance, they can literally just build the VMs in our environment and move their applications over pretty
And just
quickly.
move them. All right. So this gives me migration path, snapshot capability, replication, template. It sounds like to me this is what I'm looking for in a software defined infrastructure layer. And I know we're working with some customers together on this stuff. And then you pulled out this crazy idea because I think you heard me talk about it once. And you pulled out and you went and bought two Nooks. Thank you, by the way, for buying Intel Silicon. I have to say
Yep,
thank
you
you.
bet.
But you bought
No,
two
they
of
run great too. They're fast. Yeah.
two of our Nooks, and you created a mini cluster. So tell me a little bit about the process in doing that.
Yeah, you bet. Can you see the two Nooks on the screen there?
Absolutely.
Okay, perfect. I forget the actual name brand of the Nooks, but they are Nook. Um, I believe they're Generation 12s, Intel Nooks. And basically what I did is for our environment, when we want an HA cluster, we needed a minimum of two nodes. So I had to get two Nooks. And then if you look at the bottom picture where it has the red cable coming out of the back of the two Nooks, both of these Nooks are dual ported. They're 2.5 gigabit network connections. That red cable basically goes from Nook A to Nook B. and that's our core network for our vSAN technology. And we replicate all the data across that. And what that provides for the end user is high availability and a very tiny small footprint. So one of those NUCs can completely go down. Someone could step on it, or maybe you're doing maintenance on it, or maybe the power goes out on that NUC and the other NUC stays up and running, and you have complete failover in that other NUC. In fact, you can if it's a cold like outage where they take the NUC comes offline by getting unplugged, or maybe there's a flood or something, but the other NUC's still up online and running, you can literally just restart your VMs on the secondary NUC and they'll come right up. So yep, and then what that does is we basically replicate the storage between both those NUCs. The cool story about this, though, is now we can take all the VMs and the infrastructure running on those NUCs, the networking, the storage, and we can replicate that to maybe a centralized data center where we have multiple sets of these HA clustered NUCs running in different environments, maybe like a point of sale environment, where they're all replicating to a single data center. So if I ever need to protect the data that's on those NUCs, I have them protected. And that's all built into our software.
All right, so this is really interesting, because what I just heard, and correct me if I'm wrong, is I can build out an environment on these NUCs, or I could build it in the data center, and then I could replicate it down to the NUCs.
Yes.
Is that true?
So you kind of stepped ahead, and I was going to get there next, but you can do it in both directions because we have bidirectional replication. And we can replicate the snapshots of the VMs. We can now take those VMs and we can replicate those up to the central data center. And or you could take, maybe you're doing updates on your builds for all your remote sites and you want to push it down to your remote sites. You can now do that with replication, where you push it down to those remote sites and you basically bring those new builds up there.
But it's not just the VMs, it's the network configuration, access it's everything, all in a nice bundle, right?
Yep, absolutely.
Including storage, so all that. So this is pretty cool, because what you've produced, what I can see is I can tie this into my DevOps pipeline, where I'm building, for example, these two NUCs can go into a store, right? Let's say I have 1,500 stores throughout the nation, right? And they need to be run autonomously, disconnected at times. I could easily in my DevOps pipeline say, hey, here's the new update to my environment that I need, and then push that out across all 1,500.
Yeah, absolutely.
That is slick, because all the networks, even the networks, can all be inside the network, all identical to each other, right? Without any problems, right?
Absolutely. And the other cool thing about it too is now I can take our replication is basically, it's WAN optimized. And so we have deduplication built into our replication. So whenever we push that data down to those remote NUCs, we're only sending out the data that's deduplicated and or changes, right? We're not having to send out a whole entire footprint. So if I have a VM, or if I have multiple VMs running on these two NUCs that I have to update, it's not going to have to go through and rewrite the entire footprint of maybe a terabyte or 2 terabytes of storage. It'll only rewrite the changes and send that down.
So that to me is super cool, right? Because I may not have great connectivity on those remote sites.
Right? That's right. Exactly. That's what I was getting at. Yep.
That's real cool. All right. So the big question I have, I think some of our listeners have as well, is, all right, these two NUCs, how much memory are in these that you're showing here?
Yeah, so these two NUCs, they can support up to 64 gigabytes each. They basically use those 244 pin DIMMs, laptop DIMMs. And right now I have two 16 gigabit DIMMs in each of them. So I have, each one of these NUCs has 32 gigabytes, but you can get them up to 64 gigabytes because it has 2 DIMM slots.
All right. So total is 64 gig is what you have on there. And storage?
In storage right now, I have 2 terabytes of SATA flash. That's basically two terabyte SSDs that are SATA drives. And then I have 1 terabyte of NVMe flash. So if I need anything that's real high performant and it can fit it in there, yeah, it has the M.2 drives. There's 1 terabyte in each system.
Oh, wow. All right. So have you done some performance testing on this? Have you run it through its courses? Can you make it tip over?
Oh yeah. The performance is actually pretty unbelievable on these NUCs. It comes close to, and this might, not to try to downsize it at all, but it comes close to running performance tests like on a local Mac. And what I mean by that is the performance is lights out. when I do things like performance testing to see my IOPS going in and out and my throughput going in and out, it's super fast, considering it's just running on two small NUCs.
That's incredible. How many VMs are you able to, and what size VMs do you think you can run on this thing without it falling over? I mean, what could I use this for? I can think of a lot of crazy things I could use this for, right?
Well,
But
you could easily use it for databases. You could use it for remote desktop, workloads, editing, workstation type stuff. It could definitely support that with the performance that's on these systems. Yep.
right, and you're running Ubuntu on them, or well, you're running your own OS on them, so you can have as many VMs on there as you want, right?
Yeah, as long as the memory and the CPU cores can support it. With your guys' CPUs, it's wicked fast, so you can oversubscribe those. Not that you need to, but then with the RAM, it's literally just, do I have enough RAM in there to be able to support the workloads that I need? And of course, if you needed more RAM and it's a small environment with these guys, you can scale these out. We only see two here on the screen,
Yeah,
but
but
I
you can
can
add another one.
easily add 3 or 4 of them in there. Yep, exactly.
Yeah, yeah, this is pretty cool. I may have to replace
Yeah.
my file server I have at home with this. So, all right, cool. Can you show us a little bit
Yeah,
about?
depending on the size of your file server, I mean, I could realistically get 15 terabytes or 16 terabytes of usable all flash just between these two NUCs. If I installed an 8 terabyte SATA SSD on each one, and we mirror the data for protection, right? So that would give you 8 terabytes usable. And I installed another 8 terabyte M.2 drive on each one. Now I'm up to 16 terabytes all flash across these two little NICs.
And it would be screaming fast too,
And it would be
and
screaming
probably
fast.
not a
Yep.
lot of heat. Probably not a lot of heat coming off of them either.
Nope. Nope. I'm sitting right next to him right now.
No, that's pretty cool.
So the two NUCs that I have on the screen there, this is basically the interface for those two NUCs. And this is our primary dashboard. And here you can see Verge, it says Verge DR. And I use these two NUCs for doing my DR replication and testing and just running workloads on in general sometimes for demo purposes. If I want to see the nodes on this cluster, I basically come over here. Here you can see node 1 and node 2. Here you can see, to keep me honest, there's 31 gigabytes on each one of those, 32 physically, but
Yep.
we're using some of that off the top. If I want to double click into one of those guys here, and there you go again, it's 12th gen Intel Core, i5 1240p, so it's one of the latest and greatest NUCs. And then I come down here, I can see my drives on my NUC, I can see my NICs, just like we saw the two NICs on the back of it, the one red cable and the one gray cable. If I want to double click on that guy, here you can see one's running at 1 gigabit or 1,000 megabits per second, and then one's 2.5. That's that red cable that's doing the crossover between the two NUCs. It's getting the native 2.5 gigahertz, which is really nice. And that basically supports my core network for my vSAN replication across both NUCs. So that's from one node. If I go back into that node, I can now see the drives. So if I want to click on that drive there, here you can see one of my drives is M.2 drive. That's my NVMe drive, 1 terabyte. And the other drive is that SATA drive, and that's a 2 terabyte drive. So each NUC has this configuration, identical configuration. So that way, when we set up our vSAN tiers, we replicate across these. So then I end up getting 1 terabyte or 932 gigabytes of usable NVMe flash, and then I get 2 terabytes of usable SATA SSD.
Very nice.
And I can confirm that because if I go back into my cluster environment and I go into my vSAN tiers, I'll show you those two vSAN tiers that are based on those drives. Here's my vSAN tier 1. You can see the tier up here. And that tier 1 is based on those NVMe drives, and you can see the capacity is 930 gigabytes. I'm only using a few gigabytes on it right now. And then here's my tier 3. That's the SATA SSDs. My capacity is 1.86 terabytes, and I'm using about 314 gigabytes on that. And if I want to double click on that to validate that, I can come here. I can see it's two drives. I have one drive on node 1, one drive on node 2. They're both 2 terabytes each. So we basically mirror across our environment. And the way our vSAN tier works, the file system works, is it's a distributed mirror. So as we scale up or scale out, depending on if your servers or your systems can support additional drives internally, or if you want to scale out. So if I wanted to add another node, I could potentially add a node 3 here with the same configuration, and they would just take that and mirror it out across those.
Nice.
Yep.
So this gives me the visibility that I need across nodes. As I add nodes to this, it'll see those nodes as well. So that's my physical layer. What about my
Yep.
virtual layer?
Yeah, so if we go into the virtual layer, I can come in here to my virtual machines. Here is my virtual machine's default dashboard. On the left-hand menu bar here, I have a bunch of configuration basically changes that I can do or settings that I can do like new VM, new drive, new NIC. And then in here I have a list of my VMs. You can see I have some VMs running here. I have my top drive rates, my top drive storage usage, my top NIC rates. But usually we spend most of our time in this environment is I go into my virtual machines, and this is where I can see a list of my different virtual machines in my environment. If I want to look at the console of one of these VMs, and you can see here, I have 4 running on the 2 NUCs right now. So these 4 are running. But I double click on this Windows VM. Here we have a guest QEMU agent. So this gives us that VM level guest information that we want to collect, like what my C drive is using, what my G drive is using, what my host name on my VM might be. So all the things that you would expect of a mature infrastructure virtualized product, right, for your on-prem cloud. And if I want to go into my console here, click on this guy. This will give me console access. Now I'm in that VM. And this is one of the performance tests I love to run to show people is this Blackmagic disk speed test utility. This was actually referred to me by a customer because they wanted me to do some testing for them. But basically, if I double click on this guy and I start my speed test here, I can come into here. I can select which target drive I want it to run on. I pick my data G drive and I go ahead and click start. And this guy takes off, and you can see automatically it's already pushing the limits of the performance I can get from just replicating the data across network on my writes. So I am limited because I have the 2.5 gigabit connection on the back end. Typically, in a production environment for customers, we'll ask that you have a 10 gig or bigger for the vSAN. But still, this is pretty good speed for just going across those 2 NUCs, right? You're not, we can pretty much support any application with this. And then as this guy finishes, you'll see it'll flip over to the reads. Here's the other nice thing too, is we just went from 180 megabytes per second to 3,000 megabytes or 3 gigabytes per second. And that's because what we do is whenever we're doing reads, we read locally from the local storage. Yeah, versus with the writes, we're always writing across to 2 different environments because we want to make sure that write data is protected.
Right, of course. So with a faster network, because you basically at 180 megabits per second, or megabytes per second, you've saturated a 2.5 gigabit connection.
Yeah, almost saturated it.
It's pretty close, right?
It's pretty close, yeah, because this could be maybe a little bit over 200 or 240. There's probably a little overhead in there for something, but for the most part, it's pretty screaming fast.
Yeah, that is pretty cool. What about network? Because Darren touted, hey, I set up my whole data center inside this thing. I can create multiple networks here and put different machines on different networks. All that is all built in here as well, right?
Yeah, absolutely. So here I can go to my network. So what I did is I jumped back into my my primary dashboard, and I can do that very quickly on this header up here. And basically, I click into my networks. And what we do is we have these tiles where you can jump into the different environments. But here you can see I have tenant networks, so subtenants that I have running in here. I have internal networks. That would be for my core, my DMZ. That's where all our services run across, like our vSAN storage and any other services that we provide.
That's your internal. That's your internal stuff. Got it.
Yeah, and then I have my external, and that would be my connection to my UI, right? Or my connection out to my northbound, southbound networking, basically my external network. And so if I click on all networks, it lists all of those together. Here you can see my core and DMZ. Here's my core DMZ switch. That's that one cross connect, that red cable that goes across those 2.5 gigabyte connections. And then my external network is at 1 gigabit. If I double click on that guy, here you can see I have my IP addresses. These are for my subtenants that I have set up. So virtual IP addresses. If I go back into my external, here's my firewall rules. So we have full firewall rule control where you can come into here and you can do things like here I have a DR synchronization rule so that I can synchronize from my production environment down to this DR environment. And that's basically how I can push VMs down to it and then import them in and run them, on demand.
Let's say I'm the sysadmin, right, at some retail store. I've got 1,500 stores nationwide. I need to manage these things remote because I don't want to hire a sysadmin for every single small store I have. Is there a way that I can manage all this from one console where I can see what's going on?
Yeah, so today we basically do it site by site. So it's a single console per site. But with our next release, 4.11, and right now we're in 4.10.3, but 4.11 comes out in a couple of weeks, we've built in geographic site management. So that means literally when you go to the primary dashboard, instead of just seeing your clusters and your nodes, there's another pane in here that shows you a geographical map where you can click into remote sites from that geographical map. And or there's a list as well to where if you already know the list name, it's like, Philadelphia versus, Seattle versus
Boy,
Portland.
I
You can
can
just click
filter.
on those list names and go right through it. Yep, exactly.
Oh, that's super cool. So I should be able on that map to see status of everything running as well. So any red things
Yep.
come up, I'm going to know. Alerts, all that stuff is built into that. That's super slick. That is super slick. So
Yeah,
Aaron,
today we just have our sites and we have our clusters, but that is coming in our next release, which is supposed to be out in a couple weeks.
oh, that is really cool. I can't wait to get my hands on that. Aaron, any last words for our audience out there listening today?
I would just say, if you're looking for some type of edge robo remote virtualization infrastructure, or if you're looking for something for your primary on-prem data centers, definitely check out Verge.io. We have a great product. It's mature, it's easy to use, and we get great responses from our customers. We get a lot of repeat business from our customers just because it's so easy to use, and it's durable. So, yep.
Now, is there a try? Is there a try option here? I heard there might be a try option where I can go and maybe download the software, install it, try it out myself for a period of time. Is there an option?
Yeah, I believe if you go to our website, and I'll probably mess it up, but if you go into here, there should be a way. If you go to videos or our blog or about Verge.io, there's multiple links where you can come in, and let's click on videos for a second, real quick. And if you watch a video, we might have even a try and buy type thing. Not a try and buy, but
Test
there
drive.
it is.
Test drive.
Test
Yep.
drive right there. Yep. And so basically, you just fill out a simple form: first name, last name, company name, your business email. We crest the test drive, and then one of our guys will reach out to you. We have a couple different ways you can try it out. You can either download our ISO and install it on your own hardware. We'll run on any hardware in your environment, x86 based hardware. We have an online demo lab that we can set up for customers too if they don't have any hardware, but they want to get to know how the software works.
Very cool. Aaron, thanks for coming on the show. Again, that's Verge.io. I normally don't like to just come out and talk about products, but you guys have done such a killer job, especially running on the Nooks. I just had to have you come on.
No, absolutely. Thanks for having me. It's always great.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.